So make sure you have those, and if you have any additional late assignments that you're adding in, please make sure to email me what those late ones are, just in case. Sometimes I miss the old ones, not intentionally, but you know, there's a lot of assignments in some of our folders and it's easy to kind of overlook something. So just in case, if you're adding some old stuff, probably be best to give me an email. Friday of last week was the last day I wanted, or I need an email if you're planning on retaking one of your old tests rather than taking the doubled high test score that's already been entered. I'll extend that if by the end of the period you also wanted, if you've rethought that and decide you want to do that. Send me an email ASAP, like before the end of class today, that's something that you want to do. The assessment period for this class is Friday at 8:15 to 9:15. Unless you're planning on doing one of the retakes, you're just going to come in for attendance and then you'll be dismissed. And also after the assessment period on Friday, I'm going to delete the shared components of OneNote. And I don't know if on my end, when I delete your shared notebook, if it's going to delete it on your end or not. I don't think it will, but it might. So it would probably be a good idea to have all that stuff backed up into the non-shared section of your OneNote before then. But otherwise, it should be, everything should be fine. Any questions with any of those parts? No. Okay. Very good. Let's go and start taking a look at homework 2 questions here. I think Amy wants to start with number 10. That's the first reference to anything I see in there, or really the only reference, but not too late to change your mind if you want to ask about anything else. And then we'll finish up what we're going to talk about today, so that should be relatively straightforward things. Okay. So looking at number 10, I noticed that this looks like it could be something that's a difference of 2 squares, because my exponent on the x is even, and I'm subtracting a constant. So I'm going to try to rewrite this as something squared minus something squared. Well, I know x to the 8th is x to the 4th times x to the 4th, or x to the 4th squared, and 1 is 1 times 1, or 1 squared. So if I use my difference of 2 squares formula, then I have x squared, or I'm sorry, x to the 4th minus 1 times x to the 4th plus 1. This is not factorable because it's addition, but this one is also a difference of 2 squares. So I know x to the 4th is x squared squared. So if we do that again, we have x squared minus 1, x squared plus 1, and we still have that x to the 4th plus 1 that we couldn't do anything more with. That one's still not factorable. Similarly, x squared plus 1 is not factorable, again because it's an addition. But x squared minus 1 is also a difference of 2 squares. That would have been just like something we factored in chapter 4, so I won't write anything down additionally about that. But this guy there is now the best that we can do. So there's no more special factoring patterns I can do, so I am finished with that one. Amy, are you happy with that?
Thank you.
Of course. Okay. Any last calls on this homework assignment before we move on to kind of wrap things up here? Alrighty. Let's hit it. So we've been talking about factoring polynomials. Last time, we talked about the sum and difference of two cubes. I'll just rewrite those formulas real quick. And we talked about the difference of two squares. And we talked about things in the quadratic form. So we talked about those three types of factoring. Today, one more. That is factoring by grouping. So factoring by grouping we'll use if we have four terms in our polynomial. And the procedure here is going to be just like something we could have seen in the previous chapter during the course of doing our long factoring technique for a quadratic. So here's an example. So I have four terms. So what I'm going to do is I'm going to break this up into two groups. And I remember between the two groups I need to have a plus sign, so I'm just going to rewrite that as plus a negative rather than a subtraction. And then from the first group I'll take a greatest common factor of x squared. From the second group we'll take a greatest common factor of -9. And then if we notice, there's a factor of x plus 2 in common to each term. So when I factor that off, I'm left with x squared minus 9. And then I should check the x squared minus 9 to see if that's still factorable. It is a difference of two squares. So I could factor that a little bit more. Let's do one more example. Maybe 8x to the 4th plus 40x to the 3rd minus 27x minus 35. So again, I noticed I have four terms. So I'm going to go ahead and make my two groups. Again, got to have an addition symbol in between them, so the subtraction I'm going to turn into plus a negative. From the first group, I notice that I have a greatest common factor of 8x to the 3rd. That leaves me with x plus 5. The second group, I notice I have a greatest common factor of -27. That also leaves me with x plus 5. I notice then that each term has an x plus 5. So when I factor that out, I'm left with 8x cubed minus 27. And then I should check to see if there's any more factoring that I can do. X plus 5 is linear, so I know there's nothing else to do with that one. But the 8x cubed minus 27 is a difference of two cubes, right? So I can think of 8x as cubed is 2x cubed, and 27 is 3 cubed. So I can factor that as a minus b times a squared minus a times b plus b squared. So it simplifies down to this. Okay. So let's go ahead and summarize what's going on here. So the first thing, if we're going to factoring, or this is a summary for these factoring methods, first thing we look for is a greatest common factor. And the next thing we'll look at is the number of terms. So if we have two terms, first thing we do is look for a difference of two squares. If there is a difference of two squares, we factor it, and then we have to start back up at the two terms box. If it's not a difference of two squares, then we'd look at, is it a sum or difference of two cubes? If it's yes, then we have to go back to the two term spot. If it's no, then we're finished. The other option is we could have three terms. So the first thing we'd want to ask is it in the quadratic form? If it's yes, then we'd want to know, is the leading coefficient equal to 1? If it's not in the quadratic form, we'll stop because we don't have any method to deal with that yet. So if it is quadratic form and its leading coefficient is 1, then we can do our shortcut factoring. If it's not, we have to do the long factoring. So if it is shortcut factorable, then we have to go check the two terms. So each of the factors that we create, we have to check to see if those are factorable with the two-term branch. If it's not factorable by the shortcut, then we stop. Similarly here with the long factor. last situation would be if we have 4 terms. So if we have 4 terms, we want to check to see if it's factorable by grouping. So if it is, we'd factor by grouping. And from there, we'd have to check factors by going to the 2-term section. If it's not factorable by grouping, then we have to stop because we don't have any method yet developed to factor that. So there's a couple of places here where we really want to be, where we're really interested in going forward. And we really are going to be interested in, during second semester, kind of filling in some of these blanks into our factoring tree. So just because I have a 3-term quadratic and it's not in the quadratic form, doesn't mean that it's not factorable. Similarly, if I have a 4-term polynomial that's not factorable by grouping, doesn't necessarily mean it's not factorable. And certainly we haven't even addressed how to deal with polynomials with 5 or more terms. So these are all areas that still need to be kind of flushed out. We'll do that in the second semester, not now. But I wanted to point that out after we kind of drew out this kind of roadmap in terms of like what to do in what situation in terms of factoring one of these polynomials. But I wanted to point out to you that this is not yet complete. We still have some work to do in second semester. So we'll do some examples here in a second using this. But for right now, are there any questions about this diagram before we move forward? We'll do some examples with it. So if you're not quite sure, I think that'll probably clear things up a little bit. Okay, fair enough. The last topic that we want to talk about is solving. So the first thing we want to do is get the polynomial equal to 0. So you might have to add or subtract things from both sides to make that happen, but that's pretty trivial. And we're going to factor this polynomial. So for right now, we're just going to be using the techniques that we've kind of outlined in that summary diagram above. And then we're going to use the zero product property to set each factor equal to 0. And then the last is to solve each factor separately. So that's kind of our outline here for the solving piece. The most difficult part of this is typically the factoring part, because there's, potentially a lot going on there. So let's do some examples. And then we'll be finished with our lesson today, and really the lessons for this semester. So let's say we want to solve x to the 6th minus 7x cubed minus 8. Well, the first thing I'd want to do is make sure that the polynomial is equal to 0. Well, clearly it is, right? So I don't have anything to do there. The next step is to factor. So let's go back up and look at our summary. So the first thing I'd want to do is look to see if there's a greatest common factor. Well, there's not, because the coefficients are 1, -7, and -8. There's nothing in common with those other than -1 or +1. And the variables on each term is x to the 6th, x to the 3rd, and then there's no x's on the last. So there's no variable in common between all the terms. So there's no greatest common factor. So we'll look then at the number of terms. So we have 3. And this is in the quadratic form because I have the biggest exponent is 6, which is twice the other exponent, which is 3. And the last term is a constant. So it does fit the quadratic form. And its leading coefficient is 1. So we should be able to factor this using a shortcut. So let's go down here and kind of do that. So if I write this so that it's really in the quadratic form, we can do that and make ourselves a little substitution so that this is exactly quadratic. And now it should be easy to factor y squared minus 7y minus 8. I just need the two things that multiply to give me -8 and add to give me -7. Well, -8 and 1 will do that. And then, though, we didn't want to solve for y or factor over y, we want to solve for x. So we have to go ahead and plug those x's back in, because I know that y is equal to x squared, or cubed, excuse me. Okay. So if I go back up and look at my summary now, what does it tell me to do? Oops. So I've gone here, I've done the shortcut, and it says go to 2 terms. So from the 2-term track, I'm going to look at each one of these factors and say, is it a difference of 2 squares? Well, clearly it's not, because each factor has an x cubed in it. Can't have an odd exponent in my variable and be a difference of 2 squares. So then it looks as if it's a sum or difference of 2 cubes. Well, yeah, both of them are actually sum and differences of 2 cubes. Right? So I'll apply my difference of 2 cubes factoring. So a minus b, a squared plus a times b plus b squared. For this factor, and then we'll do the same thing for the other one. So a plus b times a squared minus ab, plus b squared. And if I look at my summary, it then says to check to see if, or go back to the 2-term sections. So I should check to see if x minus 1 and x plus 1 is factorable. And clearly they're not, because they're both linear. So we would be done factoring. So now what I would do is I'm going to take my zero product property and set each of these factors equal to 0. And then we'll solve each of these factors independently. So for x minus 2 is equal to 0, we'll add 2 to both sides. For x squared plus 2x plus 4, this is a quadratic. That's part of the result of a sum or difference of 2 cubes. So I know this isn't factorable, and I need to use the quadratic formula on it. So negative b plus or minus square root b squared minus 4ac all over 2 times a. So 4 minus 16 is negative 12. And because it's a negative 12, I know I'm going to get an I. And the square root of 12 is really the square root of 4, which is 2, times the square root of 3. And all that's still over 2. And I notice the negative 2 and the 2i in the denominator, everything contains a factor of 2. So I can reduce that all just to make a negative 1 plus or minus I root 2. So those are my answers for that piece. We go on to x plus 1. We'll just subtract 1 from both sides. And then our last piece, x squared minus 1, or minus 1x plus 1 equals 0. Again, this was the result of a sum or difference of 2 cubes. So I know that this piece is not factorable. So I have to use the quadratic formula. So there's negative b plus or minus b squared minus 4ac all over 2 times a. So 1 minus 4 is negative 3. And because that negative sign underneath the square root, I know I'm going to get an I. And the square root of 3 can't be simplified anymore because 3 is a prime number. So I'm left with this as my answer. So each of these 4 boxed pieces make up our 6 solutions. Really, each of these with the plus or minus is 2, because you have one solution that has the addition symbol there and another solution that has the subtraction symbol there. So there's really 6 solutions here, but only 4 boxes, because we wrote with the plus or minuses to make it a little bit more compact. And you're free to do that. Or you could write them separately. It doesn't really matter to me. The convention would be to write them with the plus or minuses, though. Questions on what we did for this one?
Mr. Kulik,
Yes.
for the x minus 2 times x squared plus 2x plus 4 times x plus 1 for that line,
Okay.
can you just explain how you got that again?
So I used the difference of squared, or 2 cubes factoring pattern. So here my a was x, and my b was 2. Is that okay?
Yep, thank you.
Yeah, no problem. So again, just filled it into the formula. Those formulas, again, will be, you'll use a lot, and I know they're unfamiliar right now. As you use them more and more, they'll get more and more familiar, and it'll be easier to recognize that stuff when as you get used to using it over and over and over again. Because particularly in this last couple of homeworks, you'll have used these a lot. So they should be getting a little bit more familiar and easier to remember. So let's do x to the 5th minus 16x is equal to 0. So the first thing we want to do is get the polynomial equal to 0. Well, it's already done for us, so there's nothing to do there. So we'll start our factoring. When I go and I look at my factoring summary, the first thing I should look for is a greatest common factor. If I notice here, both of these contain a factor of x. I'm going to begin by factoring that off. And then I'm just going to worry about factoring the remaining part. So that x on the outside is just going to come with me all the way to the end. I'm not going to worry about it again until we, break everything up using the zero product property. But during the factoring process, that x is just going to hang out front full of everything that I do. So x to the fourth minus 16 has two terms. First thing I do is check to see if it's a difference of two squares. Well, x to the fourth is x squared squared. And 16 is 4 squared, so it definitely is. I can rewrite that as x squared minus 4 and x squared plus 4. Again, notice that x is just kind of coming along for the ride with me. Now, x squared minus 4 I recognize is another difference of two squares, just like it would have been in the previous chapter. But x squared plus 4 is not factorable because of this addition symbol there, so I won't do anything to that. And now I'm fully factored, right? So, when we apply the zero product property, I can set each of these factors equal to 0 and solve each of them separately. Well, x equals 0. That's done already. Add 2 to both sides. Subtract 2 to both sides. And now this one is quadratic, and it's not factorable, but I don't need to use the quadratic formula on it. I mean, I could. There's nothing wrong with doing that. But I could also solve this directly since there's only x squareds and not also x's. So I just subtract 4 over square root both sides. Because I square root both sides, I get a plus or minus. Because I'm square rooting a negative, I get an I. And the square root of 4 is just 2. So there is my result. Any questions on that one? Okay. Let's do one more example, and then we'll be finished for the day. So x to the fifth plus 6x to the third minus x squared equals 0. So again, first thing I would do is to make sure the polynomial is equal to 0. It already is, so there's nothing to do there. So now we'll start trying to factor, or look for a greatest common factor to factor this. If I look, though, there's nothing in common with all 4 terms. So there's no greatest common factor. So the next I go is I look for the number of terms. I see I have 4 terms here. So if it's factorable, I'm going to need to do the factor by grouping. So I'll make my 2 groups with an addition symbol in the middle. Notice that I just turned that minus x squared into plus and negative x squared. So in the first group, I notice I have a greatest common factor of x cubed, leaving me with x squared plus 6. And in the second group, I notice I have a greatest common factor of negative 1, again leaving me with x squared plus 6. And each term has an x squared plus 6 in common, and leaving me with x cubed minus 1 left over. So if I go back and I look at my summary again, where were we at? So we had 4 terms, we did grouping, it was possible, now we need to go to 2 terms. So the x squared plus 6 is not a difference of 2 squares because of the addition, and it's not a sum or difference of 2 cubes because the exponent is 2. So we can stop on that one. Now the x cubed minus 3, again, not a difference of 2 squares because the exponent is 3. but it is a sum or difference of 2 cubes, so we need to do that factoring. So we'll go down there and do that. So this piece we said was not factorable, but this one is a difference of 2 cubes. So when I apply that, I get a minus b times a squared plus ab plus b squared. And then I should check x minus 1 to see if that's factorable. And we can see right away, because it's a linear term, it's not going to be factorable anymore. So I'm not even going to bother like walking that through the 2-term end of my tree there. So now I can just set each of these equal to 0 and solve. So x squared plus 6 equal to 0. Well, I can solve this directly, or I could use the quadratic formula, but I think it's a little bit quicker to just do this directly. So I'll subtract 6, square root both sides. I get a plus or minus from the square rooting of both sides. I get an I from the negative sign under the radical. And the square root of 6 I can't simplify because it's just 2 times 3, and neither of those are square rootable. And the next one I'll just add 1 to both sides. And this one we've done already using the quadratic formula. That was negative 1 plus or minus I root 3 over 2. So I just didn't write out the work for it. I just copied down the answer because we solved this one just a few minutes ago. You guys are okay with me taking that shortcut there? Saving a little bit of writing. And again, that's something you're obviously free to do on your homeworks or tests or anything. If you've already done like one of these little quadratic solving problems and you run into it again, you can certainly just copy the answer and say, I already did this in number 7 or something. That's definitely something you're free to do and really are encouraged to do. In mathematics, we're looking for efficiency. And if you don't have to repeat work because you noticed that it's the same problem you already did, then just cite your other problem and just move on with your day. Any questions with that one? Okay. Well, your final assignment for the semester is this homework 3, for chapter 5. And it's just 10 solving problems. So it's 10 of these solved by factoring problems. Some of them will be relatively quick. Some of them will be a little bit more challenging. They're not really in order from hardest to easiest or most to least challenging or anything like that. They're just kind of all jumbled up. If you're not sure what to do with the factoring, really look at that factoring summary that we made there. I think is often going to be quite helpful for you. And that'll kind of do it for us. This is the final assignment for the semester. It'll be part of the homework check that'll happen tomorrow morning at 8 a.m. is when everything is due. Again, if you had old assignments that are still pending that you wanted to try to get turned in, that's fine. Make sure you email me and tell me what to look for so that I make sure that I see it when I'm going through and doing the homework check tomorrow morning. Any final questions from you guys? All right. Well, if you're happy, I'm happy. So you guys can type bye into the chat, and we'll see you guys on Friday.